Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So far, 7 problems I have completed on simplex method. First 3 problems on maximization type. Next 3 problems on minimization type. 6th problem, 7th problem we have done on mixed constraints. When we have mixed constraints, some inequalities are less than equal to type and some inequalities are greater than equal to type and some are equations itself. All mixed constraints. In that case, we have to include slack variable, surplus variable, artificial variable. The only thing is calculations should be correct, accurate, and that you can get only by practice. So if you just watch the video, you cannot be able to get the complete command unless you practice those problems and watch the video 2-3 times. And if you have not watched the earlier videos, I suggest you go to the playlist of my channel, select the subject Operations Research, select the videos of linear programming simplex method, be perfect, then only you can get the good command. So before starting the 8th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Now see the 8th problem. Solve by simplex. Maximize z is equal to 4x1 plus 5x2 minus 3x3. Subject to constraints x1 plus x2 plus x3 is equal to 10. Already it is an equation. So only artificial variable is required for this equation. The second inequality, x1 minus x2 greater than equal to 1. And third constraint, 2x1 plus 3x2 plus x3 less than equal to 30. And non-negativity restriction x1, x2, x3 will be greater than equal to 0. This is the problem. First of all, it's a mixed constraint. One equation greater than and less than. Secondly, it is a maximization problem. Remember this point. Now, this is the original problem. Now, introducing the slack variable, surplus variable and artificial variable, we can convert the LPP into a standard form for solving by simplex. So, objective function, original objective function 4x1 plus 5x2 minus 3x3. Now, we have one slack variable. In this less than equal to type, we have to add the slack variable. For greater than equal to type, we have to subtract the surplus variable and add the artificial variable. So here 4x1 plus 5x2 plus minus 3x3 plus 0 into S1 plus 0 into S2. Already every problem, whether it is minimization or maximization, the coefficient of slack variable and surplus variable will be 0. This is the coefficient. And minus MA1, new point, first time we are coming across. If the problem is maximization problem, then you should take the coefficient minus M. If it is minimization problem, you should take it as plus M. Note it down. Always while watching the video, I suggest my viewers to keep a notebook, pen, calculator ready. So whenever I explain some new point, important point, immediately note it down. So for maximization problem, minus MA1 and minus MA2. Subject to constraint. The first is equation itself. So only artificial variable will be added A1. So x1 plus x2 plus x3 plus A1 is equal to 10. Second, it is greater than equal to type. So minus S1 plus A2. Because A1 already we have given here. Now we take A2. So x1 minus x2 minus s1 plus a2 is equal to 1. Third one, it is less than equal to type. So we have to add the slack variable. So plus s2. 2x1 plus 3x2 plus x3 plus s2 is equal to 30. Now we have to keep artificial or slack or surplus variable value. The other values will be taken as 0. For example, a1 should be taken as 10. A2 should be taken as 1 and S2 should be taken as 30. Remaining all variables we should take it as 0, and initial solution is obtained by taking x1 is equal to 0, x2 is equal to 0, x3 is equal to 0 and S1 also is equal to 0. S1 also equal to 0, but don't take S2 is equal to 0 because S2 is equal to 30 we have taken, right? Now first simplex table is very easy to make because we don't require any formula, don't require calculations. Simply we take the coefficient of all this LPP. Now first of all CJ, coefficient of objective function in this row and column. So here x1, x2, x3, s1, s2, a1, a2. These are the variables, right? The coefficient of objective function 4x1. So here x1 4, 5x2, x2 5, minus 3x3. The coefficient of x3 is minus 3. So write down minus 3. S1 is 0, S2 is 0. Whereas A1 is minus M and A2 is minus M. Same. Here A1 is equal to 10. Here we have taken A2 is equal to 1 and S2 is equal to 30. The coefficient of A1 is minus M. See here. And coefficient of A2 is also minus M. And coefficient of S2 is 0. Right? Now, in this body of this table, we take the coefficient of constraint. Coefficient of constraint. The first constant is 1x1, 1x2. So here x1, 1, x2, 1. And x3 also equal to 1. And a1 is 1. So a1 is 1. Take all other values as zeros. Second constraint, 1x1. So x1 is 1. x2 is minus 1. So in x2 we take minus 1. Then s1 is minus 1. s1 is minus 1. And a2 is 1. a2 is 1. Take other values as zeros. Last constraint, 2x1. x1 is 2. 3x2. x2 is 3. And 1x3. So x3 is 1. S2 is 1. So here S2 is 1. Take all the other values as zeros. That's all. Now we need the Zj value. Multiply the Cj value with the variables. Now carefully you see. Because here only the students will commit the mistake in calculations part. And particularly here minus sign is there. So be careful. So first minus m into 10. It is minus 10m. Then plus into minus will become again minus. Minus m into 1 is minus m. 0 into 2 is 0. So minus 10m minus 1m. So minus 11m. This will become minus 11m. Here minus m. Minus m. Plus into minus will become minus m into 1 is m. So minus m, it will become minus 2m. Here be careful, minus m and minus m. If we add up, it will become minus 2m. We are not multiplying. Don't multiply, minus into minus will become plus. Minus m will become minus 2m. Right? Here minus m. Minus m. Then minus into minus will become plus. Plus m. That is equal to 0. 0 into 3 is 0. So here comes 0. Here minus m. So here it is minus m. Minus m into 0 is 0. And 0 into 0 is 0. So it will become minus m. Here this one 0, this one 0. Minus into minus will become plus. Plus m. Here 0, 0. This one also 0. Here minus m into 1 is minus m. Right? This 0, this 0. Then 0 minus m into 1 is minus m. That's all. These are the Zj values. Now Cj minus Zj. Cj is on the top. Minus Zj. So 4 minus, see here. 4 minus minus 2m. So minus into minus will become plus. 4 plus 2m. 4 plus 2m. Here 5 minus 0 is 5. Here minus 3. Minus 3 and minus m. Minus 3 minus minus m. So what it will become? Minus 3. Minus into minus will become plus m. So m minus 3. We can write it as m minus 3. Here 0 minus m is minus m. 0 minus 0, 0. Minus m minus into minus m. So minus m minus into minus plus m, that will become 0. Then minus m minus into minus m. So minus m plus m, that will become 0. So now optimality test. The optimality test for maximization problem says all the values should be zeros and negatives. Zeros and negative. Write it down immediately. For maximization problem, all the index row elements, this is the index row, Cj minus Zj. All the elements should be zeros and negatives. Zeros and negative. If any positive value appears, then most highest positive should be selected. Here we can't say which is negative and which is positive. Here 0, 0, 0, negative is there. But out of these three, which is negative, we don't know. So we have to suppose, let m is equal to 10. Why I am taking 10? Because 10 is greater than 4, 5, minus 3. Any value which we take should be more than the actual values. So 10. So first one is 4 plus 2m. 4 plus 2 into 10. 4 plus 2 tens are 20. That is equal to 24. Second one, m minus 3. That is equal to 10 minus 3. That is equal to 7. Here already it is minus 1. It is minus 7. All the values should be zeros and negative. Here already negative. Leave it. This is zeros. Here out of these three are positive values. First one 24, second one 5, third one 7. Highest positive should be selected. Highest positive. The highest positive is 24. For which column? This one. So x1 will enter in the next table. When we make the next table, x1 will enter. Right? Now which will depart? It depends on minimum ratio. What is the minimum ratio? 10 by 1 is equal to 10. Here 1 by 1 is equal to 1. Here 30 divided by 2 is equal to 15. Out of these three, the minimum in this minimum ratio is 1. For which variable? A2. So what will happen? In the next table, simplex table 2, x1 will enter and a2 will depart. So here I am writing x1 enters and a2 departs. So in place of a2, I am writing x1. Remaining a1 as it is. Then in place of a2, I am writing x1. And third s2 is remaining same. The coefficient of a1 is minus m. a1 is minus m. x1, the coefficient of x1 is 4 and s2 is 0. That's all. We have prepared the table. We have prepared simplex table 2. Now we have to find out the variables. So for finding out the variables, first we need the values of the entering row. Values of entering row. Values of entering row. Values of entering row. Entering variable. Which is the entering variable? x1. So we need the value of x1 is equal to values of departing row. Departing row is which one? A2. Divided by intersectional element. Same thing what we have done in the previous problem. So departing variable are 1, 1, minus 1, then 0, then minus 1, then 0, 0. I am not taking the value of 1 because A2 is departed, so no need to open the column of A2. Divided by, what is the intersectional element here? 1. So all divided by 1. So what are the values that will remain? 1 divided by 1 is 1. 1 by 1 is 1. Minus 1 divided by 1 is minus 1. 0 divided by 1, 0. Minus 1. Here 0. And last one also 0. So we got the values of x1 entering variable. Here x1 values are 1. Then again 1. Minus 1, 0. Minus 1, 0 and 0. Now we need the values of A1. Values of A1 is equal to old values of A1 minus intersectional element into values of entering variable. Remember, the formulas are same. Every problem, whether it is maximization, minimization or mixed constant, these formulas are same. So values of A1 is equal to old values. What are the old values of A1? 10, 1, 1, again 1, 0, 0 and lastly 1. We are not taking this A2 because it is departed. Minus intersectional element of A1. A1 intersectional element is what? So 1 into values of entering variable. Entering variable are 1, again 1, minus 1, 0, then minus 1, then 0 and lastly 0. That's all. So 10 minus 1 is 9. 1 minus 1, 0. 1 minus into minus will become plus. 1 plus 1 is equal to 2. 1 minus 0, 1. 0 minus. Minus into minus will become plus. 0 plus 2 is 2. 0 minus 0 is 0. 1 minus 0 is 1. We got the values of A1. 9, 0, 2, 1, 2, 0 and lastly 1. Right? Now values of S2. Values of S2 is equal to old S2 minus intersectional element into values of entering variable. Values of entering variable. So old values of S2 are 30, then 2, 3, 1, 2, 3, 1, 0, 1, 0, 0, 1, 0. That's all. We are not taking this last one. Minus intersectional element of this S2. What is the intersectional element is 2. 2 into. Now values of entering variable. What are the values of entering variable? 1, 1, minus 1. 1, 1, minus 1, 0, minus 1, 0 and 0. That's all. Now you can easily find out the values. 2 into 1 is 2. 30 minus 2 is 28. 2 minus 2, 0. 3 minus into minus will become plus. 2 ones are 2. 3 plus 2, 5. 1 minus 0 is 1. 0 minus into minus will become plus. 0 plus 2 is 2. 1 minus 0, 1. 0 minus 0 is 0. That's it. These are the values. So 28, here 0. This one is 5. Now comes 1, 2, 1, 0. That's all. So we got all the values of A1, X1 and S2. Now Zj value. Multiply. Multiply the Cj value with the solution value. So minus 9m. So see here. Minus 9m. Minus m into 9 is minus 9m. Plus 4. Plus 4. Right? 0 into 28 will be 0. So 4 minus 9m. We can write 4 minus 9m. Here. Minus m into 0 is 0. 0 into 0 is 0. So 4 ones are 4. Here minus 2m. Minus 2m. Plus into minus will be minus. Minus 4. So minus 2m minus 4. Minus 2m minus 4. Here minus m into 1 is minus m. 4 into 0 is 0, 0 into 1 is 0. So here comes minus m. Here minus 2m, this one minus 2m, plus into minus, minus 4. So minus 2m, minus 4, minus 2m, minus 4. Last one, minus m into 0, 0. 4 into 0, 0. 0 into 0, 1 is 0. Here minus m into 1 is minus m. That's all. So we have calculated the zj value. Now cj minus zj. So simply 4 minus 4, 0. Here 5 minus 2m minus 4. Here minus 3 minus m. Minus into minus will become plus. So m minus 3. Again I repeat, minus 3 and then minus m. So minus 3 minus into minus will become plus m. So m minus 3. Next one, 0 minus 2m minus 4. Last one, 0 minus m plus m will become 0. That's all. Now after calculating this, the optimality ratio. The optimality function says if it is a maximization problem, all the index row elements should be zeros and negative. No positive element should be there. But here we suppose m is equal to 10. So first one is 5 minus minus 2m minus 4. Minus 2m minus 4. So 5 minus 20. Minus 2m means minus 20 minus 4. So 5 minus 20 and minus 4 will become minus 24. So 5 minus into minus will become 24. That is equal to 29. So this one is 29. Yeah, m minus 3. 10 minus 3 is 7. 10 minus 3 is 7. Now 0 minus minus 2m minus 4. Minus 2m minus 4. So here 0 minus 24. So 0 plus 24 is 24. Now which one is highest? The highest value is minus 29 for this value, x2. So x2 will enter. x2 will enter. And which one will depart? 9 by 2 is equal to 4.5. Here 1 divided by actually minus 1 we should not calculate. 28 divided by 5. 28 divided by 5, how much you will get? 28 divided by 5 you will get 5.6. So 5.6. So which one is the minimum? 4.5 is minimum. So A1 will depart. So in the next table, one more table we have to make where x2 will enter and A1 will depart in simplex table 3. Come on, now we have prepared the simplex table 2. In simplex table 2, the entering variable is x1. x1 enters and A2 departs. When A2 is departing, no need to open the column of A2. We require only up to A1, right? So here A1, in place of A2 I have written x1. Now S2 will remain same. The coefficient of A1 is minus m, here you can see. And coefficient of x1 is 4 and coefficient of S2 is 0. First of all, we need to calculate the values of the entering variable. Entering variable is x1. x1 enters. So the formula is the value of the departing variable divided by intersectional element. The values of the departing variable A2 is 1, 1, minus 1. So here you can see 1, 1, minus 1. Then 0, minus 1, 0. 0, minus 1, 0. And lastly 0. We are not taking the value of A2 because it is departed. Divided by intersectional element is 1. So divided by 1. So 1 by 1 is 1, 1. Minus 1 divided by 1 is minus 1. 0 by 1 is 0. Minus 1 by 1 is minus 1. 0 by 1, 0. 0 by 1, 0. So we got the values of the entering variable x1. So what are the values? 1, 1, 1, minus 1, then 0, minus 1, and lastly 0 and 0. These are the values of the entering variable x1. Now we need the values of a1. How to find out the values of a1? Old value of a1 minus intersectional element into values of the entering variable. Same formula we are applying. The old values of a1 are 10, 1, 1, 1. So 10, 1, 1, 1. Then 0, 0, 1. 0, 0, 1. These are the old values. Minus intersectional element of a1 is 1. So here 1 into values of the entering variable are 1, 1, minus 1. So 1, 1, minus 1, 0, minus 1, 0, minus 1, 0, 0. Now see here, 10 minus 1 is 9. 1 minus 1, 0. 1 minus into minus will become plus. So 1 plus 1, 2. 1 minus 0, 1. 0 minus, minus into minus will become plus. 1 into 1 is 1. Then 0 minus 0, 0. 1 minus 0 is 1. So these are the values of a1. Now I am writing the values of a1. 9, 0, 2, 1, 1, 0, 1. Now we need the values of S2. Same formula, old values of S2 minus intersection element into values of entering variable. Old values of S2 are 32, 3, 1. So here 32, 3, 1. Then 0, 1, 0. Here 0, 1, 0. Minus intersectional element of S2 is 2. Take 2 into values of the entering variable 1, 1, minus 1, 0. 1, 1, minus 1, 0. Then minus 1, 0, 0. Minus 1, 0, 0. Now 2 into 1 is 2. 30 minus 2, 28. Right? And 2 minus 2, 0. 3 minus into minus will become plus. 2 ones are 2. 3 plus 2, 5. 1 minus 0, 1. 0 minus. Minus into minus will become plus. 2 ones are 2. 1 minus 0, 1. 0 minus 0 is 0. So these are the values of S2. 28, then 0, then 5, 1, 2, 1, 0. So we got all the values of A1, X1 and S2. All the values. Now we need to calculate ZJ value. This one. So now carefully you have to multiply. Minus m into 9 is minus 9m. Right? Then plus 4 ones are 4. Plus 4. Plus 4 ones are 4. 0 into 28 is 0. So 4 minus 9m we can write down like this. Minus 9m plus 4 or 4 minus 9m. Anyway you can write. So 4 minus 9m. Now I am coming to the next one. Minus m into 0 is 0. 4 ones are 4. 0 into 0 is 0. So 4 ones are 4. Here minus m into 2 is minus 2m. Minus m into 2 is minus 2m. Plus into minus will be minus. Here minus plus into minus is minus 4. So minus 2m minus 4. Again I repeat, minus 2m. Then plus into minus will be minus. 4 ones are 4. So minus 2m minus 4. Minus 2m minus 4. Here minus m 0 0. So minus m. Here minus m. Then plus into minus minus 4. So minus m minus 4. Here 0 0 0. Here minus m. That's it. So we have calculated all the values. Now Cj minus Zj. 4 minus 4, 0. 5 minus 2m minus 2m minus 4. Minus 4. So minus 3 minus into minus will become plus. M minus 3. How? Minus 3 minus m. Minus m. So minus 3 minus into minus will become plus m. So m minus 3 we can take. 0 minus m minus 4. Here 0 minus 0 is 0. Minus m minus into minus plus m. So it will become 0. That's all. Now we have to suppose let m is equal to 10. Already I told you, value of m can be anything which should be greater than the actual coefficient of objective function. Actual coefficient is 4 or 5. So we are taking let m is equal to 10. Then first one, 5 minus 2m minus 4. That is equal to 5 minus 2 into m is 2 into 10, 20. Minus 20 minus 4 is minus 24. That means 5 minus into minus will become plus 24. It comes to 29. So first one we are getting 29. Second, m minus 3. 10 minus 3 is 7. Then 0 minus, second one, 0 minus m minus 4. 0 minus 10 minus 4 is minus 14. So 0 plus 14 is equal to 14. Now whichever is higher, highest positive we have to select. So 29 is the highest positive. So this 29 is this one. So in the next iteration, next table, x2 will enter. x2 will enter. And which will depart? Now depends on minimum ratio. 9 divided by 2 is equal to 4.5. Then here dash, because denominator minus, we should not calculate. 28 divided by 5. So 28 divided by 5, you will get 5.6. So 4.5 or 5.6, whichever is lower, 4.5. So A2 will depart. So in the next table, that is table, simplex table 3, A1, x2 will enter and A1 will depart. In the next table, simplex table 3. Now, in simplex table number 2, we have decided that x2 will enter and x1 will depart in the next table. That is table number 3. Simplex table number 3, x2 enters and a1 departs, right? So this is the table. Now, so in place of a1, here a1 was the first row. So a1 is departing. In place of a1, I am taking x2. Remaining two rows, same variables x1 and s2. x1 and s2. The coefficient of x2 is 5, x1 is 4 and s2 is 0. First of all, we need to calculate. And one more thing you remember, when a1 is departing, there is no need to open the column of a1. Once the artificial variable is departed, you should not open that artificial column. If surplus or slack variable is departing, still we should open the column of S. Now, first of all, we need the values of the entering variable. Entering variable is x2. So here values of entering variable x2. The formula is values of the departing variable divided by intersectional element. What is the value? Which variable is departing? A1 is departing. So values of A1 are 902. So here I have taken 902. 1, 1 and 0. So 1, 1 and 0. I have not taken the value of A1 because A1 is departed. No need to take. Divide by intersectional element is 2. So 9 divided by 2 is 9 by 2. 0 by 2 is 0. 2 by 2, 1. 1 by 2, 1 by 2. 0 by 2 is 0. So we got the values of the entering variable x2, right? So x2 values, I am taking it down here. 9 by 2, then 0, 1, 1 by 2, again 1 by 2, and last one 0. So we got the values of entering variable. Now we need the values of x1. How to find out the values of x1? Old value of x1 minus intersectional element into values of the entering variable. Same formula we are repeating in every case. The old values of x1 are 1, 1, minus 1. So here 1, 1, minus 1. Then 0, minus 1, 0. 0, minus 1, 0. That's it. Minus intersectional element of x1 is minus 1. So I have taken minus 1 in the bracket. Multiplied by values of the entering variable. Entering variable are 9 by 2. 0, 1, 1 by 2, 1 by 2 and last one 0. That's it. Now simplify it. 1 minus into minus will become plus 9 by 2. 1 plus 9 by 2. If LCM is 2, 2 ones are 2 and 2 will get cancelled, 9 remains. 11 by 2. Similarly, 1 minus 0 is 1. Minus 1. Minus into minus will become plus. Plus 1. So minus 1 plus 1 will become 0. Then 0 minus. Minus into minus will become plus. So 0 plus half is half. Then minus 1. Minus into minus will become plus 1 by 2. So minus 1 plus 1 by 2. So LCM is 2. 2 ones are 2. Minus 2 plus 1. So it will become minus 1 by 2. And last one, 0 minus 0 is 0. So these are the values of x1. So I am taking down the value 11 by 2, then 1, 0, then half, then minus 1 by 2, and last one is 0. So we got the value of x1. Lastly, we need the values of s2. The old values of S2 are 2805. So here I have taken 2805, 1, 2, 1. Here also 1, 2, 1. Minus intersectional element is 5. So minus 5. Into values of the entering variable 9 by 2, 0, 1, 1 by 2, 1 by 2, 0. Now simplify it, 28. 9 5s are 45 by 2. If we take LCM 2 into 28 will become 56. 2 will get cancelled, 45. So 56 minus 45 is 11 by 2. See, 0 minus 0, 0. 5 minus 5, 0. 1 minus 5 by 2. So LCM is 2. 2 ones are 2. 2 will get cancelled, 5. So 2 minus 5 is minus 3 by 2. Similarly, 2 minus 5 by 2. 2 minus 5 by 2. LCM is 2. 2 2s are 4. Then 2 will get cancelled, 5. So 4 minus 5 is minus 1 by 2. So 1 minus 0 is 1. So we got all the values of S2. So what are the values? 11 by 2. 11 by 2. Then 0. Again 0. Then minus 3 by 2. Next one is minus 1 by 2. And last one is 1. Here 1. That's it. Now we need to calculate the ZJ value. So multiply. Carefully you see here. 9 5s are 45. 45 by 2 plus 4 into 11, 44. 44 by 2. So if you take LCM 2, so 45 plus 44 is equal to 89 by 2. 0 into 11 by 2 is 0. So 89 by 2. Similarly, 5 into 0 is 0, 0 into 0 is 0. So 4 ones are 4. 5 into 1 is 5. 4 into 0 is 0, 0 into 0 is 0, 5. So 5 into 1 by 2 is 5 by 2. Plus 4 into 1 by 2. 4 into 1 by 2 is 4 by 2. So if we take the LCM, because 0 into 3 by minus 3 by 2 is 0 only. So LCM 2, 5 plus 4 is 9. So 9 by 2. Here 5 into half is 5 by 2. Plus into minus will be minus 4 by 2. That is equal to LCM is 2. 5 minus 4 is 1 by 2. So here it comes 1 by 2 because 0 into minus half is 0. So 5 into 0, 0. 4 into 0 is 0. 0 into 1 is 0. That's it. Now we subtract. 4 minus 4, 0. 5 minus 5, 0. Minus 3 plus 9 by 2. Minus 9 by 2. Minus 3 minus 9 by 2. So if we take the LCM 2, 2 3s are 6, minus 6 and minus 9. So minus 6 minus 9 is minus 15 by 2. So here it comes minus 15 by 2. Here 0 minus 1 by 2 is minus 1 by 2. 0 minus 0 is 0. That's all. So optimality test says all the index row elements should be zeros and negatives. There should not be any positive. If positive value appears, we have to open another simplex table. But fortunately, we got all the values are zeros and negative. So we reached the optimum solution. So ultimately you should write the conclusion, since all the index row elements are zeros and negative, we reached the optimum solution. The optimum solution is x1 is equal to 11 by 2, x2 is equal to 9 by 2, and x3 is equal to 0, because we don't have x3 in this answer. Only we have x1 11 by 2, x2 9 by 2, and z value is 89 by 2. We don't require s2. So the final answer, x1 11 by 2, x2 9 by 2, and z value is 89 by 2, x3 is 0. That's all. So this is the end of this problem, problem number 8. One more problem is left, that is problem number 9. That will be the end of all these three methods: maximization, minimization, and mixed constraints. Then last one we have duality problems. So inshallah the next problem, problem number 9, will continue in the next video.